Welcome, everybody. My name is Amir Abbas. I am one of the senior product managers at Google Cloud. I focus on a product called Gemini Code Assist, which helps developers increase their developer productivity using AI. Today, I thought what we would do is just kind of talk about where we were, where we are, and where we're headed. And I'm going to try to use an analogy to explain this. So just let's talk about the evolution of AI coding assistance. Before we get into that, it might be actually good to talk about some interesting findings that we just released. No more than a week or 2 weeks ago, we just released the latest DORA report, the state of AI assisted coding. And I just want to just put this picture up there that what we found in 2025 out of about 5,000 respondents is that AI's primary role in software development is that of an amplifier. It is not replacing humans. We are not being taken over by the AI overlords. We are using this to amplify our workforce, which a lot of us can kind of relate to. A lot of us want to do more with less. And how are we going to accomplish that? This report is available to you for you to digest. It's a short 140-page report. We will send you the link of what this report looks like. I also wanted to add one more sort of key finding from this report. And if you look at this particular chart, and this is in the executive summary portion of this report, you can see that with AI adoption, a lot of these metrics are improving or enhancing or amplifying, right? Individual effectiveness, organizational performance, the amount of time people do doing valuable work, the amount of code quality is going up. Some of the orange ones, we want those to be kind of in the negative. So you can see friction has actually gone down. The burnout has about stayed the same. And software instability is about stayed the same as well. But a lot of the other sort of positive metrics have improved. So we're definitely seeing adoption of AI tools, and we're definitely seeing people using them in a more productive fashion in 2025 and beyond. So before we get into that, let me just kind of talk about where we came from. I've been working on this product for the past 2 years or so. So I've had the privilege of seeing sort of the improvement and the rate of innovation of these particular products. So I want to kind of talk through that particular thing. Imagine you're in 2023, early 2024. These tools are just starting to kind of uptake. A lot of folks are using these tools. The models are not quite thinking yet. And so what happens in this particular world is you're starting to use the chat as a way to get information back. And this chat is very limited. You can think of this chat as what I like to call a single step inference, right? And all that means is that I can only give it one thing at a time to do. So let's just ask something very simple. So here I am inside of my IDE, inside of the chat interface. I have not started talking to it yet, but let's ask it a simple question. So I'm in Los Angeles, so I will just say something like, hey, what is the weather right now in LA? So once it's completed, it's gone through its process. You can see that it's bounded in its knowledge. We are directly interfacing with the LLM. So I asked it a question. The LLM came back, rightfully so, and said, I can't give you real-time information. I am bounded by what I have been trained on. Similarly, so this is, of course, a non-coding task. But let's say that I want to actually perform a coding task. So I'm going to open up a new window. And again, I'm in this sort of single-step inference world right now. So this is the world of the past. And I'll just ask it to do something very simple. I'll just say something like, create a simple terminal-based tic-tac-toe game, right? A very, very simple task. Okay, so it's completed the task. So if you notice, I just asked it to create a tic-tac-toe game. And what it's done, it's given me steps to do, right? So it said, here's a README file. Here's the actual file. It's picked Python because I didn't really signify what language I wanted to do. And then at the very end, this is the important bit right here where it says, to play the game, I have to save the file. It does not have access to save these files and then run this particular thing. And then if I get into an error, then I have to figure out how to push this particular thing back. So the analogy that I like to give, I like sports. So the analogy that I like to give is that we were in this sort of a player model. So in this particular case, I'm very interactive with the tool. I'm acting like a player. So since we're in the NFL season, I'll just give the NFL analogy. So imagine that you're a quarterback. In this particular case, I'm quarterbacking this particular play. If there's an error, if a receiver is not open, I have to figure out, maybe do a check down or maybe just throw the ball away or something like that. I am very much in the loop at every single play by play. So that's an example I give within this sort of a non-agent way of doing coding or non-agent way of talking to anything. A couple of things. One is that I am directly interfacing with the LLM. And then so prompt engineering was very important in this particular phase, in this era of AI assistant coding. I had to know exactly how to prompt it. Everybody was learning prompt engineering 2 years ago. And it's because you were interfacing directly with that particular thing. And then, it doesn't matter whether this worked or not, but you can kind of see that it might up the developer productivity, but you're very much interacting with this. You're doing one task at a time. You can't multitask. You can't context switch. You have to really sort of use your cognition to pay attention to exactly what's happening, just like you would if you were a player. Every play is important. You're not trying to win the game. You're trying to just execute the play. So keep that analogy in mind. Where we are right now is what I like to call the agentic era of coding. And for that, I am going to actually switch tools. So I'm going to go into my CLI and I'm going to show you a tool called Gemini CLI. And we'll talk a little bit more about this. Gemini Code Assist exists in a myriad of surfaces. So what I showed you before was an IDE plugin inside my VS Code. And what I'm now showing you is Gemini CLI, which is a terminal-based tool. But this tool is now built with agents in mind. So actually, I'm going to ask the same question just so I can kind of prove the point. So I'll just say, what is the weather right now in Los Angeles? So in this case, you can see that it's taking my intent and it doesn't know directly what the answer is, and it's using a tool to go and fetch the answer. So in this case, it's using a Google search tool, right? And now it's gotten me the answer back. So what in the agent world, what it's trying to do is it's really trying to take my task, figure out what my intent is, and then it will do any means necessary to actually execute that intent. Where previously it wasn't executing anything. It was just giving me a bunch of knowledge. It was giving me a bunch of information. And then it was up to me to figure out how to save those files, how to execute those files, and what to do with that particular thing. And so as I'm talking through it, the biggest thing to think about in this agentic era is that I am not directly interfacing with the large language model. I am interfacing with a piece of logic. Let's just call it the agentic loop or the agentic logic. We'll talk a little bit more about that. And that agent is now talking to the LLM. And that agent has two things going for it that pre-agentic era did not. One is that it is now interfacing with thinking models. So we're using the thinking capabilities of the models to decompose the task into individual discrete tasks and then execute them. And secondly, it has access to tools. It can do things in the outside world, if you want to use that. For example, this was a very simple example, is that it can use tools like Google Search. It can read files. It can write files. It can edit files. It can do research. It can talk to external systems, databases. It can talk to source code management systems like GitHub or GitLab. It can talk to your internal systems. Perhaps you have your Confluence or your Wiki pages or your Jira pages. Because remember, when developers work, they don't just work inside the IDE or inside the terminal. They're interfacing with lots of tools, right? They're interfacing with documents, they're interfacing with issues, they're interfacing with task management systems and those types of things. So let's just say that I want to build something. So I'm going to clear this. And the biggest thing about these agents is how do you coach them to do the right thing? So I'm going to take my analogy that I talked about with the player thing, where in the player, I was executing the plays. Now in this agent world, I'm the coach. I am not actually executing the play. I didn't tell it to go do a Google search. I just said, I just need to know what the weather right now is in Los Angeles. It looked through its list of tools and it found the right tool. It had a bunch of other tools that are available to them too, but it found the tool that made sense to it to accomplish that particular task. So let's give it a coding task. In this particular case, I'm going to have it plan something for me. The way I treat these agents is just like you would treat a pair programmer. These agents are starting to feel and act a lot like humans, in my opinion, right? Because they can think and they can follow instructions. You can teach them how to do certain things. You can think of them as part of your team. These are kind of your virtual teammates or your pair programmers. And just like with any task, I'm not just going to have it just start coding things. I'm actually going to have it, plan something for me. So I'm going to go ahead and clean this up. All right. So let's plan something. Let's do something a little bit more exciting than a tic-tac-toe game. I don't know. But I'm going to create a new plan. So I'm giving it a task. And let's just say, let's create a URL QR code generator. Now it's going to take that intent. It's going to send all the tools that are available to it to the model. And it's going to ask the reasoning capability, the thinking capabilities of the model to figure out how to do this. Notice that my prompt is very generic. It's very small. I didn't say which language. I didn't say anything else. All of that, I've coached it. It's almost like giving it the playbook, just like a coach would. A coach is not responsible for individual plays. I'm not going to babysit every single play, what's happening. I've already given it the playbook. So I've said, whenever I ask you to plan something, I need you to create a plans folder. Anytime it does something to the outside world, so in this case, it wants to create something, it's going to ask me permission. And I'm going to go ahead and allow that. Yes, go ahead and create a plans folder. And you can see that it's generated this plans folder here. Then it's going to take my intent, and then it's going to figure out how to decompose that particular thing, how it's going to execute that particular task. So in this case, I've asked it to create me a text file, a markdown file. And you can see that it's written this markdown file. And it's asking me, hey, I need to write a file inside that plans folder. I'm going to go ahead and allow that. All right, so it's created this plan for me. And you can see that it says, hey, I've created the plan and I've saved it, and my task is now complete. So the task was not to create the QR code generator. The task was to create a plan for the QR code generator. And at this point, again, if I'm interfacing with this particular thing as my pair programmer, I'm just saying, hey, let's work on a plan together. And it's created the plan. So now we can review the plan. So I like things in writing, and that's why I asked it to create a plan. I also like to see just a quick checklist at the very top. I can just review that. Okay, it's going to create a new Git branch. That's really good version control practices. It's going to create stuff in Flask. That's great. I've already instructed it that if I don't tell you very specifically which framework to use, always use Flask. Then it's going to implement the QR code logic, create the HTML front end, which I didn't ask it to do, then test it. I've asked it to always practice test-driven development, and then review something and then test everything. If we scroll further down, you can see that it's created much more information. What the architecture should look like. Flask, QR code, what are some of the challenges? What are some of the prerequisites? It's already given step-by-step instructions to itself on what it's going to do. So part of this is it's kind of like it's coaching itself. It's creating its own playbook. I've given it sort of the generic set of instructions. And now it's saying, I want to create a branch that looks like the date and the name of the task, which is exactly what I've asked it to do. What the file names should be, exactly the way I want it to do, and what port to run it on. So you can kind of see that all of these in a pre-agentic world, I'd have to do manually one by one. It would just give me information and I would say, okay, I've done this. Now go ahead and create this particular file. And then it would say, go ahead and copy this file. I've done this. In this particular case, I wanted to basically do everything from end to end. So let's go back. This plan looks good. Now I can also, just like a pair programmer, I can also have a conversation with it. I can also go back and forth and I can refine this plan. If I want to change something, if I want to add documentation, or if I want to change the port or whatever you want to do. But just for the sake of this demo, let's actually just implement this. So I'm going to say /plan : implement. So these are, again, instead of instructions, these are custom commands that I've basically instructed it to do. But this time I'm going to do something different. This time I'm going to press Control-Y, which puts this into YOLO mode. Why not? We only live once. And all that means is that go ahead and implement this plan without asking me for permissions. Now you may say that that's very risky. Why am I just allowing a tool to do something? And this is where the plan becomes very important. Because I trust that the plan is sound, and I also trust that my instructions on how to do the implementation is good, and it's also doing things with good Git practices, things like it's creating a new Git branch, it's creating constant Git commits, all of those things. And you'll notice something that as it's kind of going on in the background, you'll notice that it's going to start checking off the steps that it's doing, right? So instead of me sort of babysitting this particular tool, now I can kind of put more trust into it. And this is maybe where the coach analogy becomes a little bit more. So this is my playbook. And at this particular point, I just wanted to go ahead and execute the plays. I don't want to babysit every single particular thing. And if we start to look at kind of what it's doing, you'll notice that it has access to a variety of tools. Things like writing files. Of course, it needs to be able to do that. Things like editing files. It needs to be able to do that. So it's written a bunch of things. Things like running shell commands, right? In this case, it needs to install a bunch of requirements and those types of things. Then actually creating a virtual environment and so on and so forth. So we're basically giving it permission. We're giving it trust to be able to do this. Now, while it's kind of doing its particular thing, imagine of these things as your virtual teammates, right? So like I mentioned, that we want to amplify ourselves. One of the things we want to do with coding assistants is not just increase developer productivity, not just 10x it. A lot of people are now talking about how do we 100x the next thing. In this particular case, as this task is happening, I can context switch and go do another task. I can open another instance of this tool, and I can go and be planning a bunch of things, or be implementing a bunch of things, or creating test plans. As long as I can come back, and as long as I know that I know what it's doing, step by step, it's executing these particular things. I don't need to see every single line of code. One of the things when I talk to senior engineers that tell me is that, hey, with these AI assistant coding tools, people are generating 2,000, 3,000, 4,000 lines of code every day. I don't have time to review that particular code. And so we want to start generating these natural language files to really highlight and to document the intent of what the developer was trying to do in that particular case. So you can see that it's generated a bunch of files. So if I'm in this URL code, QR code generator folder, it's created the test and the app, templates, and it's going to kind of do its thing. Even at the very end, this is something that I just kind of did it for my own sake. I have it create this stats file, right? So I can kind of see it took 300 seconds total to create that thing. One commit. This is how many number of lines of code that were changed. This is how many number of characters that were added. So again, I just want to know for every task, just give me the quick stats. How much time did I save? So one of the things we measure at Google is velocity of developers. So things like time in second for a particular task can really help you. All right, so it looks like it's done a bunch of things. It's running the server. It looks like it also kind of killed the server. Let's just see if that particular server is running. So I'm going to switch my screen, and you can see that I've got a QR code generator running. I'm just going to go ahead and give it a URL and see if this works. Okay, so it's generated the URL. If you have time, we can actually go to this URL, and what it should do is it should take you to the GitHub page of the CLI tool that I was using, which we'll kind of talk about here next shortly. So you can see that, of course, this is a very simple example, but you notice the amount of tasks that it did. Created the plan, decomposed that plan into a bunch of discrete steps. For each of the steps, it had access to tools that it can utilize to perform all of these steps. It told me along the way what it was doing. It even provided stats for me, and it even ran the server for me, so I can just run it. If it goes into an error, then it tries to fix itself. So this is why I use the term agentic loop. If there's an error, either running the server, the web server didn't start it perfectly, which is totally fine. That's exactly how humans would work, right? We are not, infallible either. As we're doing these tasks, something would happen, and we would take that error and we would try to figure out what that error is. All of this is now context for this particular agent. It uses that to better itself. So this is the coach analogy. So this is the era where we are right now. If you are a business, an enterprise of whatever size you are, these are the types of tools you want to use, and we'll talk about some of the tools that are there. The last thing I want to talk about, which is kind of where we're headed. And in order to do that, let me just kind of take you to the tool that I was using. So this is the repo for Gemini CLI. This is one of the tools that I was using. It is an open source tool. Anybody can use it. We even have a free tier version, which we'll link in the notes, so you can see. You can see that it's got a lot of interest. There's almost 80,000 stars, almost 9,000 forks, lots of issues. So there's a lot of interest in this particular thing. What I want to show is so far what I've been showing you is a player mode of interacting with these tools, which is very interactive. The humans are very much in the loop. At every given step, there's an action that a human has to take. to the coach mode, which I like to call semi-interactive, where, I'm just triggering, I'm giving it my intent, and then I'm letting the tool kind of run free a little bit within the bounds. I've given the security bounds, hey, do everything locally, do everything in a Git branch. So if something happens, I can always reverse it. So I'm semi-interactive with that. To kind of, it's a little bit of a stretch with this analogy to what I'm calling the owner mode, which is completely non-interactive. And what that means is other actions are triggering this tool to perform certain things. So for example, we use Gemini CLI to actually code Gemini CLI, as you can imagine, for pull requests. So if I go into these pull requests, as people are submitting pull requests, so let's just open one of them. It doesn't matter, this feature one, for example. As people are submitting pull requests, we are using Gemini CLI in non-interactive mode to review this pull request. So you can see right here where it says Gemini Code Assist, the bot. Anytime a PR is created, an instance of that Gemini CLI is run inside GitHub Actions. It takes that particular PR. It gives me a summary of changes. I didn't have to interact with it at all. It gives me exactly what's happening. And then it does a code review inline, right? So it tells me, and for every single suggestion, it tells me whether it's critical, high, medium, low from a security perspective. It gives me suggestions, so I can either take those suggestions in line or I can bundle them up. But you can kind of see that we're using GitHub Actions, in this case, completely non-interactively. So in the sort of this owner mentality, the way I think about it is that you have these agents, kind of you're not responsible for the plays, you're not responsible for even the playbook or winning the game. You're responsible for running the franchise. It's kind of the best sort of words I can use for the analogy. I have my workflows automated in certain places. In this particular case, for example, for a PR. Like I mentioned, code review is a very important step, but it's very hard for humans to review code, especially in this AI agentic world where you're getting lots and lots of code being generated by these tools. So it's good to have the first pass being done by these particular tools. And that's exactly what we're doing. And this is a live, living, breathing project. So I wanted to show you a real example of that. So again, just to sum everything up, where we were the player modes. We were interacting directly with the LLM. We were the agents. We were the quarterbacks. We were responsible to decompose a task and then give the LLM a single task at a time. And then we took the actions. Yes, it upped the developer productivity, but not so much because, again, we're very much in the loop and there's a lot of sort of cognition that we had to use and we couldn't really do multitasking. Where we are right now is the agent mode. Now we have something between the human and the LLM. Let's call it the agent. That's your pair programmer. You can train it. You can instruct that pair programmer to the way you like to code. And maybe in a future session, we will talk about how to do context engineering, which is all about how do you make these agents conform and contextualize and tailor to your environments and your needs. So for example, I showed you a very simple workflow. I planned something and then I implemented something. But throughout these steps, I did not need to sort of watch every single thing that was going on. I let the agent execute those particular things on its own. And then this non-interactive or this owner mode, which is, a CI/CD pipeline is very large and very huge. You might be doing security analysis. You might be doing documentation. So you decide which parts of these things you don't want any humans in the loop, at least on the first pass. So for example, a PR first pass, we don't want any humans in that loop. So I will end with just kind of talking about kind of the entire agentic ecosystem, especially when it comes to software coding. I know like agents is a very ubiquitous, universal, cosmic term that everybody uses. So what I talked about is box number one. I'm a product manager on Gemini Code Assist. So I showed you tools inside the IDE as well as inside the CLI. And this is how you can use an agent-based tool to write software development, to do software development. This is great if you start thinking of them as your virtual employees, as your virtual teammates, however you want to call it that. And you can personalize them to the world's end, and we can talk about that. For office workers, for non-developers, we have something called Gemini Enterprise. And this is a custom agent platform. This is how maybe in software development, you can think of that as I'm a PM. I review a lot of PRDs. I write a lot of CUJs and PRDs. I can use Gemini Enterprise to help me refine PRDs or help me write PRDs. Vertex AI, one level even below than Gemini Code Assist, It is a platform to run any AI application. So in software development, you may, if you are using, let's say, custom languages and you want to fine tune the model, or you want to pick the model, you want to pick the platform that you want to run this thing in, you want to pick the architecture, maybe you want to use ADK, A2A, LangGraph, whatever technologies you want to use, gives you full customizability. Of course, with great power comes great responsibility. So a lot of skill set required, a lot of operations and maintenance required, but we kind of give you a full gambit of solutions there, regardless of which resolution you want to kind of come in at. And lastly, we have Jules, which is tackling a very specific use case of software development, and that is purely asynchronous coding. I kind of give you this a sneak peek at the owner sort of a model, which is this idea of completely non-interactive coding. And that's exactly what our friends at Google Labs are trying to accomplish, which is how can we get humans further out of the loop? Because the more you get humans out of the loop, the better productivity you're going to get. So it is an agent that runs in Google's infrastructure for, think of it for long running jobs, for maintaining, upgrading libraries, for modernizing, Java versions and those types of things. Integrates with your GitHub, gives you a branch. It's a very neat experience. Hopefully this was useful. If you are an IT leader or a decision maker that is trying to figure out how to upgrade your software delivery performance and your developer productivity, I highly recommend you read the latest DORA report. We will link that in the notes. If you're a software engineer that has not used these tools, I recommend starting with Gemini CLI. It's the quickest way to start getting coding, and it's the quickest way to start building amazing things. I can't wait to see what you guys make of it, and we'll see you in the next one.